Hello guys, it's me Sir Ernest and today we're going to continue our demonstration for part 1 of our experiment on friction. Okay, so previously what we did is we varied this object's mass and then we measured using this graph the time before it starts to move and the maximum static friction found here and the kinetic friction using this graph. Okay, so you will notice here that whereas the time it takes for the object start to move doesn't really depend on the weight of your object. In fact, it would depend on the way that this object is being pulled by the actor or by you. For example, if you are going to use uh, an actual apparatus. But what's important here is that even if you're going to do this experiment over and over again using the same mass, while the time before it starts to move would differ, you will notice that the maximum static friction and the kinetic friction would remain the same. Now, the question is, how do we determine the coefficient of static friction and kinetic friction given these values? Now, the key ingredient here is to determine the normal force. Now, how do we determine the normal force? Now, this is your setup earlier. This is your object, and this is your surface. Now, we're going to use Newton's laws of motion in order to determine the normal force. In this case, we need to identify the forces acting on this object. So here we have there are three forces acting on the object. Number one would be of course, the normal force. This normal force would always be perpendicular to the surface and it is acted on our object. The second force would be the tension on the wire. This tension on the wire is the same tension as the one that we measure in our force sensor here. And then lastly, of course, this object has weight. So we identify this as our weight. Sometimes we call this the gravitational force. And the magnitude of the gravitational force is just the product of the mass of your object and the acceleration due to gravity, where the acceleration due to gravity g is equal to 9.8 meters per second squared. How do we get the normal force? We are going to use Newton's first law of motion, where it states that the sum of forces acting on the object along the vertical direction, let's call that y, is equal to 0. From our picture here, let's not forget, by the way, that there is also a frictional force here. This frictional force can be static friction as long as this object is not yet moving, and this becomes kinetic friction once that the object would start to move. Okay, but what we're more concerned about, the computation of your normal force. Now, all the forces acting on the object along the vertical direction is just the normal force and the gravitational force. Since these are forces, therefore there are vectors. Therefore, we need to know, or we need to indicate the direction of these forces. Now, if we're going to apply this sum, anything upward is positive by convention, and anything downward would be negative. So in this case, the sum of the forces acting along y would be equal to Fn, which is positive, and then minus Fg or mg. And this is equal to 0. Okay, so naturally, using some algebra, the normal force will just be equal to the magnitude of the weight. I repeat, the normal force is not equal to the gravitational force, but only to the magnitude of the weights. Okay, so in this case, what we have is, for example, for trial 1, the object's mass is 100 grams. So this is zero point 0.1 kilograms. Of course, we're going to use MKS system. And then we're going to multiply this to 9.8 meters per second squared. So therefore, we now have 0.98 newtons. So we're just going to write here 0.98 newtons. Now, from here, we can actually calculate the frictional force. So by definition, the frictional force, whether it is static maximum, so frictional force, maximum static friction, would be equal to the product of the static coefficient of static friction mu s, this one, and the normal force. And the kinetic frictional force Fk, which we calculated here, would be equal to the product of the kinetic coefficient of kinetic friction mu k times the normal force. Okay, so let's compute for that. So we'll notice that mu s will just be the quotient between maximum static friction 0.11 and the normal force, which is 0.98. And the answer here is 0.112. On the other hand, the coefficient of kinetic friction will just be equal to kinetic friction 0.07 newtons divided by normal force Fn, which is 0.98. And the answer is 0.071. Okay? And then you will do the rest of the trials. Okay? Again, reminder that whenever you click this arrow up or arrow down as you increment the object's mass, you will not be able to return to the original or the previous values that you previously had. Okay, so you have to be careful in dealing dealing with this simulation. Okay, so that's it. That's part 1 of our virtual experiment. In the next video, we're going to answer part 2 of this experiment. Okay, so thank you guys for watching, and I'll see you guys in the next video. Bye-bye.